Welcome back to Joint, Conditional, and the Two Laws That Run Everything, Part 2 of 8. In Part 1, we built Sam's joint table of momentum return and market regime. Now, we do two things: collapse the table into its margins, and then make the central move of the whole subject, conditioning. Conditioning is the mathematical name for using what you know. It is the move a trader, a lender, or a risk manager actually makes, acting not on the average day, but on the information in front of them right now. The numbers in the margins of the table, the row and column totals, are the marginal distributions. The marginal of y tells you how often each regime occurs, ignoring the return. You get it by summing across the row, which collapses the x dimension away. From the row totals, the probability y equals 1 is 0.70, and y equals 2 is 0.30. Calm days are about twice as common as stormy. Likewise, the marginal of x comes from summing down each column. Minus 2% has probability 0.20, 0% 0.45, and plus 2% 0.35. The word marginal is literal. These distributions live in the margins, and the operation is exactly what a clerk did to total rows and columns. Nothing deep yet, just bookkeeping. The deep idea is next. A marginal answers, what does a random day look like? A conditional answers a sharper question, given that today is stormy, what does the return look like? That is the question people act on. Here is the mechanics. To condition on y equals 2, stormy, walk into the stormy row. The three joint probabilities there are 0.15, 0.10, and 0.05. They describe stormy days, but they only add to 0.30, not 1. Because stormy days are only 30% of all days. To turn them into a proper distribution over the stormy world, divide each by that row total, 0.30. In general, the conditional distribution of x given y equals the joint divided by the marginal of y, valid whenever that marginal is positive. Doing the division for the stormy row gives 0.50, about 0.333, and about 0.167. Three numbers that now sum to 1. Repeat for the calm row, dividing by 0.70, about 0.071, 0.50, and about 0.429. Look at what conditioning revealed. Unconditionally, the portfolio is up 2% about 35% of the time, but given a calm day, it is up 2% about 43% of the time, and given a stormy day, only about 17%. The regime genuinely shifts the return distribution. Rearranging the definition gives the multiplication rule. A joint probability equals the probability of the condition times the probability of the outcome given the condition. We lean on it constantly. To summarize Part 2, marginals collapse one variable away by summing across rows or down columns. Pure bookkeeping. Conditioning takes the joint table, restricts it to a single row, and rescales it into a valid distribution by dividing by the marginal. It revealed that Sam's return distribution genuinely depends on the regime, which is the empirical content of momentum behaving differently across volatility regimes. In Part 3, we show conditioning runs both directions, return given regime or regime given return, and that second direction is Bayes' rule in table form.